Uh, Good afternoon and welcome to this video. It's going to talk about topic number 5, Pure Mathematics 3, and we are going to look at example 6, which is saying solve these equations giving your answers in exact form. And the first equation you're supposed to solve is e raised to power 2x plus 3 is equals to 7. And I want us to make some follow-up of what we have learned in the previous video. And we have learned that the graph of natural logarithm of x is the inverse of the graph of ex. That one we have to keep remembering, because in any case we need to be going back to that fact. This is part A. Now, introducing natural logarithm on both sides, we are going to have ln e raised to power 2x plus 3 is equals to natural logarithm of x of 7. And I want to say something, that natural logarithm is the same as log to base e. So even if we wanted to use, we can now introduce the long method and ln to be substituted by the log into base e of e raised to power 2x plus 3 is the log into base e of 7. And we know something that the log into base a of b raised to power c is c log to base a of b. Now c was an index, it becomes a coefficient of the whole thing. And I just want to give a practical example on this, whereby we have log to base 10 of 100, which is 2, and it can be written in terms of log to base 10 of 10 squared, which is in another way 100. This is equals to the index 2 log to base 10 of 10, which is 2 times 1, and the final answer is 2. Why times 1? Because log into base a of a is 1. That one should never escape your mind. Log to base a of a is 1. So in what we need to do, bringing this now argument into this, whereby we are going to have log to base e of e raised to power 2x plus 3 is equals to log to base e of 7, which is log to base e of 7. So the index now becomes a coefficient, and we write it 2x plus 3 multiplied by log to base e of e, which is equals to ln 7. And I've just said log to base a of a is equals to 1. And it follows that 2x plus 3 is equals to ln 7. And that is the truth, because this is multiplied by 1. So if you want to solve x, x is easily ln 7 minus 3. ln 7 minus 3 and everything over 2. ln 7 over 3, ln 7 minus 3 and everything over 2. Well, you may separate the terms in the way you know how. So you could have x is equals to a half ln 7. X could be equals to I have ln 7 minus 3 over 2. That is after taking the denominator to affect each and every term. That is easily understood. But I want us to just go to part B of the same. That was part A. Let's look at part B. Part B, we are talking about 2 ln x plus 1 is equals to 5. Let's take the whole numbers across and have 2 ln x is equals to 4. And this is already a multiply. If we write this one in an extended kind of way, or rather even before we take that step, we can divide both sides by 2 and by 2 and have ln x is equals to 2. We said that ln x is simply log to base e of x, which is 2. And we are going to use the understanding that the inverse of ln x is ex. The inverse all of ln x is simply ex, and therefore x easily becomes e raised to power 2. Before we can go further, we can bring the other understanding that we've just learned about log to base e of x. Log to base e of x is equals to 2, and this is in logarithmic notation. If we wish to bring this one is in index notation, like we said, log to base 10 over 100 is equals to 2. So we are easily going to administer or introduce the anti-clockwise movement and have it like e raised to power 2 is equals to x. And that one is exactly what we had realized earlier on. So whichever way you find easier, then you will always be home. But let's just introduce part C, which is e raised to power 2x plus 5 e raised to power x is equals to 14. And this one is having an index that is having power 2. And therefore we suspect we are going to have a quadratic equation, and we only have to let it be. So e raised to power 2x plus 5 e raised to power x minus 14 is equals to 0. And we can already say this is e raised to power x squared, because this is what it means, plus 5 e raised to power x minus 14 is equals to 0. So we can say let y be e raised to power x. And you're going to have y squared plus 5y minus 14 is equals to 0. When we solve this quadratic equation using probably the factor method, we're going to have a 7 and a minus 2. So y squared plus 7y minus 2y minus 14 is 0. The first two terms y is common, so y plus 7 minus 2y plus 7 is 0. And it follows that now y plus 7 is equals to 0, or y minus 2 is equals to 0. If this is true, then y is equals to negative 7. And if this is true, but y was e raised to power x is equals to negative 7. And remember, since e raised to power x is always positive, we cannot have e raised to power x equals to negative 7. It is not possible. So this one is not possible. That one is not going to be possible as far as mathematical relationship is concerned. So we are left with only one option, whereby y is equals to positive 2. And if this is true, e raised to power x is equals to positive 2. And again, if we simply employ the anti-clockwise movement, we are going to say, if we say this is 10 squared is equals to 100, then we are going to say log to base e of 2 is equals to x if we employ the anticlockwise movement. You can also remember that it's at the natural logarithm of x is the inverse of e raised to power x. So either way, you will be home. But of course, you know log to base e is natural logarithm ln. So easily, you're going to have x is equals to ln2. And that is just like what you found. So understand this was a bit long because we had to introduce quadratic equation. But either way, we've landed there. Please visit my YouTube channel, Pearson Edexcel Mathematics, International Mathematics by Mr. Kamotho, and subscribe and share widely. All right.